So for a problem like this one, number 18, the initial A is 0.90 molar, B is 2.50 molar, and at equilibrium A is 0.10 molar. What's the value of K? So what we'll do is we'll set up a little table here. So we'll start up here. We'll have, we'll have 1A plus 2B gives 3C. Now over here we'll have the initial, and down here we'll have the equilibrium concentration. Now the initial concentration of A, we're told, is 0.90. The initial concentration of B is 2.50. And the initial concentration of C is 0. So we're assuming here that all we have are just these reactants in these concentrations. Now at equilibrium, it'll be 0.90 minus some amount, which I'm calling Z. The amount of B will decrease by double that because it's 2Z, so it's going to be minus 2Z. And when these reactants go down, of course, the product can only go up, and that's going to go up by an amount of 3Z. So you can see that what goes in front of the Z is just the coefficient in front of A, B, and C, respectively. The next thing we have to do is calculate a value of Z. What we're told here is that equilibrium A is 0.10, so I know that 0.90 minus Z equals 0.10. So when I do the math there and calculate Z, it comes out to be 0.80. So that's my Z value. That's what gets subtracted and added over here as well. So the next thing we do is we calculate what A, B, and C actually are at equilibrium. So A is equal to 0.10 molar. That's given. B is equal to 2.50 minus 2Z equals 2.50 minus 2 times 0.8, and that would be 0.90. Now C is going to be 3Z, and that's going to be 3 times 0.8, which is going to be 2.40 molar. So once we've got these values, we can go ahead and calculate K. K is always products over reactants, so it's going to be C to the power of 3 because of the 3 in front of the C. Then we've got A and B squared, and the B is squared because of the 2 in front of the B. So we go ahead and we plug all those values in. These are all equilibrium values here. This is the equilibrium constant, which is only valid when we're talking about equilibrium, and these are all equilibrium concentrations. So C is going to be 2.40 molar, that's cubed, divided by A, which is 0.10 molar, and B squared, which is 0.90 molar, and that's all squared. So that comes out with a value in your calculator of 170.677, or 667 or something like that. It keeps on going out. Now if I take this down to 2 significant figures, it'll just be 170, and that could be the answer that you would put in here. We can calculate a unit as well, but for K we typically don't include a unit, so just put this number in the box, and that's all you'll have to do.